Okay, welcome back for part 2 of our conductors and insulators review. So you have this question that was on the review sheet, and it's basically talking about you want to keep your cinnamon rolls warm. Now, if you think about this, when you cook cinnamon rolls, they're in an oven that's at least 350 degrees. Okay, so you bake them, so they're baked at 350 degrees. Then you're going to put them in these different types of material and let them set for 20 minutes, and then you take the temperature to see which material kept it the warmest. It started at 350 degrees. This is some of this background information that you have to bring into play when you're thinking about how to answer this stuff. So you have cinnamon rolls at 350 degrees. Now you have them in all of these different temperatures right here. And your goal is to see which one kept it the warmest. Well, if you look through here, the warmest one is the 300 degrees. The coolest one is going to be this one down here at 75 that was wrapped in aluminum foil. Okay, so what does all that mean? You scroll down and go down here, okay, you can see we have kind of a range going on here. A good insulator is going to be the one at 300 degrees, because if it's an insulator, they are, what do we say up here in part 1? Insulators heat up slowly and they lose heat slowly. So if your cinnamon roll is 300 degrees still after 20 minutes, it's losing heat very slowly and it's going to be a very good insulator. As opposed to if you go down here, the one that's 75 degrees, that one lost heat really quickly. Started at 350 degrees, now it's down to 75 after 20 minutes. It's going to be cold before too long. Okay, so sometimes you can't always think of conductors and insulators as things that transfer energy easily. Or heat. Sometimes you have to think of which one's going to lose heat quickly and which one's going to lose heat slowly. Conductors lose heat very quickly, okay, and insulators lose heat very slowly. You can see over here on the side, I have insulators do not transfer energy easily. It takes a lot of energy to heat them up. It also takes a lot of energy or a long time for them to cool off. Okay, so why are things good insulators and good conductors? This goes back to the specific heat thing. For some students, that's been kind of confusing. Specific heat, if you remember, is the amount of energy that it takes to raise the temperature of a particular substance by 1 degree Celsius. Now, specific heat, we've been talking about it in very general terms. Specific heat is kind of like, for different substances, it's kind of like fingerprints are for human beings. Every human being has a distinct fingerprint. Every human being has a distinct set of DNA. Every substance has a distinct specific heat, and there's actually numbers that go along with it. So that's why certain metals, even though metals typically are good conductors, that's why there's some metals that are better conductors than others. That's why there's even some metals that are such good conductors that they're not really good or safe to use for like electrical wiring, because they get way too hot, like aluminum. Aluminum used to be great for wiring in your houses. It's not anymore. It gets way too hot and can cause fires. Not really good. Great conductor, not very safe for your house. Okay, so I have a couple videos that I posted on Edmodo. Some of them we've seen before in class about the other science teacher with the 2 blocks of black material with a conductor and insulator, and he actually ends up going through conduction, convection, and radiation. Has some good stuff to it. There's also one about the Christmas story, which I'm going to show you, and I'm going to actually pause it and talk while it's going, so check out that one if you're still confused. Okay, thanks for tuning in.